to video 2.2, predictions and residuals. So in this video, we're going to make some predictions using a regression line and talk about some residuals. So I've continued our example from when we were describing a relationship by including our example with our heat bills and temperature. We have our negative line with the regression line. Here's the equation of the regression line, and here we see a residual plot. So remember, when we're looking at a residual plot, we're looking for no obvious curved pattern, and we had talked about some curved patterns where you might have your residual plot and you have everybody above, and then you go to the middle and everybody's below, and then you have everybody above again. So there's a very obvious curved pattern, and we had all positives, then all negatives, and then all positives. Or you could have the opposite, where you had all negatives, all positives, and then all negatives again. So there's still this very obvious curved pattern. So that's what you want to look for. And so when I look here on this side, we have people, we have data points above and below. In the middle, we have data points above and below. On the right, they're just above, but we don't have this obvious pattern. So we're going to say there is no leftover pattern in this residual plot. And so what that means is this data is linear. So we want to remember that no pattern in the residual plot means the data is linear. All right, so let's take a look at our questions here. We want to find the predicted bill for a month with the average temperature of 42 degrees. Okay, so I'm going to use how I wrote it on the other side. We're going to find a predicted bill for a month where the average temperature is 42 degrees. So we're going to plug 42 in for the temps. So we got 273.58 minus 3.6, and the x variable is temperature, so that's where I'm going to plug in the 42. And I'm going to get a predicted bill amount of 122.38. Okay, so that's how much it was predicted to be. So the actual bill for a month with an average temperature of 42 degrees Fahrenheit was $120. I want you to calculate and interpret the residual. So remember that a residual is the actual minus the predicted. So in this case, the actual bill was $120 minus the predicted bill of 122.38, which gave us a residual of negative 2.38. So to interpret this, what does that mean? That's what we're saying. So the actual bill for that month was $2.38 less than the predicted bill. And I'm just going to say what the predicted bill was of 122.38. So the actual bill for the month was $2.38 less than the predicted bill of 122.38. Okay, my next question is a linear model appropriate for the data set? Well, we were just talking about that. Remember, you can look at the scatter plot. It looks pretty linear. Then we look at our residual plot, and we can see there is no leftover pattern in the residual plot. So we're going to say yes, linear model is appropriate, because there is no leftover pattern in the residual plot. All right, So that takes us through making some predictions using our regression line. That's what the whole purpose of a regression line is, for making predictions. Okay, but what if the data appears nonlinear? So what if our original scatter plot instead it started off kind of linear, but then we have an obvious curve going on. You can see we have this curve that's happening here. So, and then our residuals, here's what our residuals look like. So when you look at that, you see there's very obviously all of them are plus here, all of them are minus, and all of them are plus again. So you get that curved pattern, not linear. This data is not linear. So they give you an equation. You will not need to calculate this line. It will be given to you. Okay, but you have to know what to do with it if it's given to you. So they want us to calculate for the average temperature of 42. So you want to plug 42 in right here into the average temp, and we will get 4.52 minus 1.57 times the log of 42, which will give us a predicted bill of $1.97. But it's not just a predicted bill. We have this log here, so we need to be sure that that word comes down. The log of the predicted bill is $1.97. Now think about it. A month's worth of heat is not $1.97. This would have been on a multiple choice answer. That would be placed there, but you have to remember, if your y has been transformed, we need to untransform the y to get the actual answer. So we need to get rid of the word log. This is really log base 10, so if we raise this side to a 10, that's going to cancel the log base 10. So we're going to do the same thing on the other side. So what that does for us is that just gives us just the bill. Just our predicted bill is going to be $93.33. Okay, so I have some AP exam tips for you for this section. And the first one is going to have to do with making predictions. So I've been saying this all year, so hopefully this is not new news to you. Always, always, always show your work. No naked numbers. And what I mean by that is if you need to grab your calculator to come up with a number, you need to be writing down how you got that number. So here, this would be showing the work for making the prediction for 42 degrees of 122.38. Do not just write the 122.38 here. You should have the entire equation written down and then your answer. Our second tip is going to have to do with our residuals. When you're finding your residual, you should think AP because we want to make sure we subtract what actually happened minus what was predicted to happen. That's the order it has to go in, otherwise you're going to be backwards. Okay, and then our final exam tip has to do with our residual plot and correlation. You do not want to use R alone to justify a linear relationship. You can calculate a correlation on anything, but correlation is only for linear relationships, for it to work. So you don't want to use correlation alone to justify a linear relationship. You want to look for a scatter plot showing a linear pattern and a residual plot for any leftover pattern. Like we did up here, we looked at the scatter plot. It's pretty linear looking, and then we looked and we determined there was no leftover pattern in our residual plot, and that's why we said it was linear. All right, so hopefully that was helpful. Let me know if you have any questions, and I'll see you in class.